Alright guys, welcome back. Today we're going to be using our Pythagoras theorem in 3D problems. And now let's look at the first example. We have a cone, which is 3 centimeters high, and it has a base radius of 3 centimeters. We need to find the slant height of the cone. So as you see, the slant height is this length over here, basically. So in order to solve this problem, we need to look at our question a little bit differently. Now just because we have a cone doesn't necessarily mean that we have to deal with volume or surface area. In this case, we're merely looking at our cone in this side view, like this. So the height is given, it's 7 centimeters. The base is 3 centimeters. And then the slant height is exactly what we're looking for. Let's call it S in this case. There you go. We have our Pythagoras triangle. We have our right triangle over here. So we can plug it into our favorite Pythagoras formula. We got 3 squared plus 7 squared equals to S squared. We don't know S, that's what we're solving for. 3 squared is equals to 9, 7 squared is equal to 49, that's equal to S squared. Our S squared is actually equals to 58. We square root that, our S is equal to square root 58. Again, we drop the minus case. If we punch that into the calculator, we're going to get approximately 7.62 centimeters. So that's it for this question. Question number 2. Take a look at the question, pause the video if you need to, and we will get back together. Okay, again, for 3D problems, it is especially very useful to draw a diagram, like this in this case. So we can see we have width 4, length 5, and height 3. A lot of people ask questions about dimensions. What does dimensions mean? Dimensions is basically a few measurements that can describe our object, right? For example, if it says in this case the floor has dimensions 5 meters by 4 meters, that means either the length or the width has to be 5 and the other one has to be equal to 4. It doesn't really matter which case it is, but in this case, for example, I'm just going to take the length 5 and the width 4. Okay, so that's what dimension means. So having this diagram over here, this is going to help us find out, at least visualize, what the question is asking. In this case, we're asking the distance from the corner point on the floor to the opposite corner point on the ceiling. So the corner point on the floor to the corner point on the ceiling, opposite. Okay, so it's basically the longest distance across the whole room, like this. Okay, in order to find the length over here, you have to kind of imagine yourself having a right triangle like this. Okay, so it's a very long right triangle like this. If you pull that out like this, okay, so you're going to get this right angle triangle. Where you don't know this is what we're looking for. We're looking for X. If we don't know this either, we're going to look for Y. And then we have 3 over here, we know that. Okay, so we're going to solve for Y first. Okay, so let's solve Y first. Okay, how do we solve for Y? Well, if you take a closer look, your Y is also part of a right triangle. With a 5 over here, and then we have a 4 over here. Right, if you take a look at this piece over here underground. Okay, so underground, you're going to have a 5 and then a 4, and then you're going to have this unknown Y over here. Okay, using our favorite Pythagoras formula, we're going to have 4 squared plus 5 squared equals to Y squared. Okay, we're going to get 16 plus 25 equals to Y squared. Y squared is going to equal to 41. In this case, our Y is equals to square root 41. Let's keep that for now, okay? We don't have to come up with a number because that's not exactly what we're looking for. Okay, again, we drop the minus case. We can substitute this into here. So again, we're going to have a new Pythagoras equation over here. We will have Y squared plus 3 squared equals to X squared. Our Y is equals to square root 41. And then we're going to square that plus 3 squared, which is 9. But let's just write 3 squared for now. And that's equal to X squared. Okay, everything very neat. We got square root 41 squared means you're going to take out the hat. You're going to have 41 plus 3 squared is 9. X squared is X squared. Okay, so your X squared is basically 50. Okay, so your X is equal to square root 50. Which, according to the calculator, is approximately 7.07 meters. And that's it for this question. Take a look. Right, this is the first time that we are kind of using the Pythagoras twice. Okay, so we use Pythagoras first time to find out one of the sides we need to know in order to solve for the unknown from our Pythagoras, which is Y. And then we use that to solve for our X, which is exactly what we need to solve for at the end. Question number 3. This is the last example of this lesson. It's a hard problem. Take a look. Pause the video if you need. Think about it. When you are ready, let's get back together. So this question provides the diagram already, so that's why we don't need to come up with one by ourselves. If we read the question a bit carefully, it says all edges of the pyramid are 10 centimeters long. This is a very, very, very useful piece of information. That basically means this length over here is 10, right? And this length is 10, and this length is 10, and this length is 10, 10, and 10, 10, 10. Right? All the edges that you can see on the outside, they're all equal to 10. Okay, so let's mark that down. So this is equal to 10. Okay, we're gonna need this one as well. This is also equal to 10. Right? Of course, the other one over here is also equal to 10, but we'll put that aside for now. So we need to use that fact to help us solve this question. We are going to find the height of the pyramid. So let's mark that down. This is our h. We need to solve for h for this question. Now, first of all, if you draw another red line over here, you will realize that you will get a right angle triangle right here. Now, the problem is I don't know how long this is. Let's go to x. But if you look at it in the side view, this is what it looks like. You're going to have a 10 over here, and then your height is this, and then your x is this. Basically, you're going to have this right triangle. But then we don't know what x is, so let's solve for x first. Okay, we can now solve for x from this right triangle because we have h that we don't know. So let's use another triangle. Okay, if you look at another triangle over here, you also realize that on the ground, the flat ground, you're going to have another right triangle. And this guy over here is actually also x. So if you take a look at this part over here, this is what your right triangle will look like. Okay, so you have 90 degree over here, and then you have your x, and you have your x, and here we have our 10. Okay, so we can have our Pythagoras formula over here. So we have x squared plus x squared equals to 10 squared. X squared plus x squared is actually going to give me 2x squared. 10 squared is 100. X squared is equal to 50. It looks like we solved that before. X is actually equal to, from the previous question, 7.07. But let's just keep that square root 50 for now, because we don't need that as our final answer. So we were going to sub this into here. And we're going to get, in this case, we're going to get, originally we have x squared plus h squared equals to 10 squared. Well, x squared now is equal to square root 50 plus our h is, again, I don't know. And that equals to 10 squared is, let's just write 10 squared for now. Okay, so we have 50, square root 50 squared equals to 50. H squared plus 10 squared is 100. Our h squared is actually also equal to 50. That means our h is actually also equal to square root 50. That means our answer is also 7.07 centimeters. And that's our final answer. Surprisingly, in this case, our x and h are both the same value. So let's finish this question together. Yesterday we got h equals to 60 over 13. And we will see if we can use this to help us solve this question. Now, first of all, just a little reminder over here that this length, this whole thing over here is actually, according to our Pythagoras, it's actually, I think we solved that before. If we call this thing over here, I don't know, let's say d. Okay, d squared is actually equal to 5 squared plus 12 squared. And our d is eventually equal to 13 actually. So d is equal to 13. So if we take the triangle out and tilt it a little bit, we were going to get this diagram over here where your hypotenuse is actually equal to 5. And the red part is, of course, our h. Our h is equal to 60 over 13. We can actually solve for this thing. Let's go to x. So in this case, we're going to get x squared plus 60 over 13 squared. Yeah, I know this is crazy, but that equals to 5 squared, which is 25. That one's easy. But we have x squared plus 60 squared is 3,600. 13 squared is equal to 169, and that's going to give us 25. I think in this case we really need to use calculator. X squared is equal to 625 over 169, exact actually. And this is actually a very beautiful number because that makes your x equal to square root 625 over 169. Now you probably know the square root of 169, this is equal to 13, so we got 13 as a denominator. But actually 625, if you take the square root of that, this is actually going to give us 25. Our x is actually not a pretty bad number. Our x is 25 over 13. That means this part right here is 25 over 13. Now we know the whole length is d, and d is equal to 13. So what is AB in this case? AB is equal to basically the whole length, which is 13, subtracted by twice of line segment over here, twice of the 25 over 13. And we're going to get 13 minus 50 over 13. This is 169 over 13 minus 50 over 13. The answer is actually 119 over 13. And that is our final answer, 119 over 13 centimeters. So that's it for today, guys. I'll see you in the next lesson. Peace.